And if the probability of success is 0.1, then probability of failure is going to be 1 minus 0.1. Okay, so, and the next one is I am told to find the probability that a random variable x is less than or equal to 4. What does this mean? Less than or equal to 4 actually means from 0, 0, 1, 2, 3, 4. So I am doing 5 of them. And if I'm told, when I'm going to calculate it, I will find in P0 plus P1 plus P2 plus P3 plus P4. Okay, if you watch the video from last class, you know that P0 means P0 is n combination 0, success to power 0, failure to power n minus 0. I'm going to rewrite it. So 0 is here, n is 12, 12 combination 0, success to power 0, and success, probability of success is 0.1, so I might as well put it in there. 0.1 to power 12, to power 0, and failure is 1 minus success. Okay, and failure is, so this is power 0, and then this is 12 minus 0, which is 12. Okay, the same thing if I'm told to find P1, I can be told to put it in the formula. It is important that you know how to put it in the formula. It's important. So if I'm told to calculate P1, I do the same thing. This is P1. P1 is equal to n combination 1, success to power 1, and failure to power 12 n minus 1. You simplify. So if I rewrite this, I have 12 combination 1, success 0.1 to power 1, and failure 0.9 to power 12 minus 1 is 11, and so on. But I'm not going to do it using this is the long method. So I'm going to do it with the short method. So I'm going to do binomial cumulative density function. So I'm going to be cumulating to the left. Binomial cumulative density function. The argument is NPR. So N is 12, success is 0.1, and the random variable is 4. 4 is included, so I have to put 4 here. So I'll pull up my calculator and evaluate this. I pull up my calculator and evaluate that. And then I'm looking for binomial CDF, so I'm going to arrow up. Binomial CDF is B. Remember that CDF means cumulating. This is area to the left, so I'm cumulating. And it's asking me what is the sample size. Sample size is 12. And the next question is, what is the probability of success? 0.1. What is the random variable? 4. And then I'm going to calculate. When I hit enter, the probability of accumulating from 4 to 0 is 0.996 to 3 decimal places. For accumulating from 4 to 0 is, that probability is 0.996. So I found that probability with calculator. You can decide to find it with in your charts, or you can actually find it using doing it by hand. Whenever you do it by hand, you take it, it's a long method. It's a longer method. And so this is number 5, practice test number 5. Practice test number 5. Okay, so the next question on binomial distribution, I'm going to go to the practice test and get another question on binomial distribution. Remember the other day, before we got into here, we reviewed the binomial distribution. We found the formula. So the formula is in chapter 6. So this is the formula for binomial distribution right here. The mean of a binomial distribution is NP, and the standard deviation is this. Okay. Okay, so I am opening the practice test again. Practice test is in Blackboard. It's also assigned in MATLAB Math. Okay, chapter 6.2 is binomial. One more example on binomial distribution, and we go to normal distribution. So we're going to do one more example on binomial distribution. And by the way, number 7 is 6.1. But let's first of all go to binomial distribution. We're going to answer another question on binomial distribution. Okay. Looking for another question number. Okay. Number 18 is on binomial distribution again. All right. So number 18 is on binomial distribution. And I'm going to clean up a little bit or just pull this up. So I'm going to pull that up so that I can do number 18 here. So I'm going back to number 18. So number 18 is on binomial distribution. So what I want to do is minimize this whiteboard so I can see the question. All right, so this question says n is equal to 10. Probability of success is 0.2, which means that probability of failure, Q, will be 1 minus 0.2. 1 minus 0.2 is 0.8. And the random variable is 2. There's an equal sign. Be careful. When there is an equal sign, it's a single probability. It's an exactly probability. So I can as well find it by hand or use calculator. So binomial probability PDF. Why am I using PDF this time? Because it's a single probability. That's what I said last class. It's a single probability. Therefore, binomial PDF NPX, and is 10. Success is P. P is 2. 2%. 20% actually. So, and therefore, the number given to me is 2. Exactly. So this is saying what is the probability that out of 10 I use exactly 2. If I want to put this in a formula, I can put it in a formula so that you know what I'm actually trying to do. This is the calculator way of doing it. But if you want to do it with formula, it is the same thing as 10 combination 2 success 0.2 to power 2 and failure to power 10 minus 2 is 8. All right, so if you evaluate this one, you get the same answer with this one. So this is by formula, this is by calculator. So I'm going to get my calculator right now and the answer. When I finish, I will also get my so how do I see binomial PDF? Like last class, I showed you how to get binomial PDF. The second distribution, second verse, you arrow up. Binomial PDF is right there. And sample size is 10. What is the probability of success? 0.2. What is the value of the random variable? It is 2. Do I calculate? Yes. So I'm going to calculate. So the probability of the random variable equal to 2 is 0.302. Approximately, it's equal to 0.302. So that probability. So that is out of 1,000, that is 302% chance of getting a 2. The probability of getting off 2 is 302 out of 1,000. Okay, so if you do it by hand with calculator only with formula, you get the same answer. Okay. So the next one is find a question on 6.1 and do an example. So I'm going to also go to the practice a question again, and let's look for a question in binomial, 6.1. Okay, so I'm looking for a question in 6.1, which they're asking us about discrete probability distribution. Okay, well, look at this question number 7. It's about discrete probability distribution. So the following data represents the number of games played in each series of an annual tournament from 1923 to 2019. So actually from 1923 to 2019, complete parts A to D. So first of all, they give you the table, frequency distribution table, and they ask you to convert the frequency distribution table to probability distribution. So convert from frequency distribution to probability distribution. Okay, so I'm going to get this table in my whiteboard right now. I'll get the table in my whiteboard. All right, so the table given to me, I'm given a frequency distribution. And the game X played, games played and frequency. How many are there? 1, 2, 3, 4. So I have 1, 2, 3, 4. 4 is the first one, 5, 6, 7. And the next one is set 19, 20. The frequency of playing the game is frequency 19, 20, 20, 37. Okay, so the first thing I want to do is to add the frequency, find the total frequency. So to find the total frequency, I put them in my, so I have 20 plus 20 is 40, 40 plus 19 is 59, 59 plus, so if let's call it 60, 60 plus 36 is 96, so we got 96. So the total frequency is 96. So I'm about to complete the table here. I'm now going to complete this table as a relative frequency table or probability distribution. Okay. So this is 4. When it is 4, I have 19 over 96. When it is 5, it is 20. Relative frequency here is 20 over 96. When it was 6, it is 20 over 96 again. This one's 5. When it is 7, it is 37 over 96. So that's the relative frequency. And that's a probability also. So we are told to convert the table from frequency distribution to relative frequency distribution or probability distribution. So I'm going to call this one the random variable x, and I'll call this one probability. You can call it probability or relative frequency. So I'm about to answer the question. The question says, graph this probability distribution. So you have to graph it. So what you want to do is you can reduce this and graph you can do it by hand if you want to. You can do it by hand. But remember that the graph of distribution, it has to be lines. They cannot be histograms. Okay, let me put it in my calculator. So let's do it together. So I'm going to put it in my calculator, and I'll get my go back to my whiteboard, and then I'm going to put x, the random variable, in L1, and probability in L2. So I'm going to clear my L1 and L2, clear L1 and L2. And then I have the numbers in my x are so the numbers in my x are 4, 5, 6, 4, 5, 6. Those are the numbers in my x. You need to get out of here for me. Okay. Okay, so here I have 4, 5, 6, 7. 4, enter. 5, enter. 6, enter. 7, enter. Supposed to put it here. This is my calculator. So I'm about to, I am in L1. So I have 4, enter. 5, 6, 7. Oh, the next one is 19 out of 96. So 19 divided by 96. Enter. And the next one is 20 divided by 96. Enter. And the next one is 20 divided by 96. Enter. And the other one is 37 divided by 96. Enter. Okay, I have made a probability distribution. Now that I have completed the probability distribution, I want to find the mean. I'm told to find the mean. I'm told to draw the graph. So I am going to go to draw the graph. So let me first of all draw the graph. Second, start plot. Hit enter. And then I'm going to draw a line graph. So I am going to draw it like a histogram, but it's still going to be a line graph. Okay, I am going to pick up histogram, and I'm going to show that I have a frequency L2, and I'm going to zoom 9, and I'm trying to zoom 9, but there's an argument here, so I will second quit. Then I'll zoom 9 on the main screen. Okay, I actually want, so I'm going to go to Windows. The X scale should be 1. The S scale should be 1, and I am going to graph this time. Not supposed to be connected. Not sure why it's connecting, so I just put the number 1 because I'm drawing. It's not supposed to be connected, so we can do it by hand, and when we finish we will need to see something like what we have in our. So I'm going to pull up my. So this is the kind of graph we're going to have because it is a distribution. It is discrete distribution. They are not supposed to be connected. But anyway, we can actually look at it here. If I find this in decimals, it will be easier to find the answers. Okay. The highest line should be, this is divided by 96, 19 divided by 96. So the longest line should be the last line. So I kind of see that my answer should look like the one that has the last line, the longest. This one should be the longest. Okay, so we check your answer when you finish. But the next thing we want to do is find the mean. To find the mean, I do one variable start. To find the mean, I do one variable start of L1. So I want to find the mean. I'll go back to that data. Is this still there? Yes. And I want to do one variable start of the data. So I go to start, arrow to calc, and I'm doing one variable start so that I can find the mean. And the mean is 5.781. The mean is 5.781. So I found the mean here, 5.781. You put it in here. And then I'm told to find the standard deviation also. I could also be told to find the variance, but I'm only told to find the standard deviation. So the standard deviation is 1.156. And actually, they told me to put it to 1 decimal place. So it is 1.2. Standard deviation is 1.2. Mean to 1 decimal place is 5.8. And that's all. So we have answered that question. So the next one is go to answer questions on normal distribution. We have already started normal distribution. So we can actually go back to that worksheet there that we used. But I want you to know that the practice test is in Blackboard. Okay. So I am going to pull up the normal distribution practice test we already have. So I am going to pull it up. All right, so it is normal distribution. We have already started with this normal distribution before. Okay, so since we already started with it, we're just going to remember how to do this because we already started it. Okay, so number 5 is saying find the area to the right. We did this before, but we're doing it again because chapter 7 has normal distribution. So area to the right of this, you draw a normal curve. For any question on normal distribution, you will draw a normal curve. This is a standard normal curve, so the mean is at the center, and the number given to me is positive, therefore it's on the right-hand side of 2.4 standard deviation as above the mean. And the question says, find the area to the right. So find the area to the right. Find the area to the right. Okay, and area so this is positive infinity. Area to the right is positive infinity from here. Well, remember that your calculator does not know how to calculate positive infinity. So whenever it is positive infinity, you write 1e to the power 99. Okay, so your calculator can now calculate area to the right of 2.4. So I can do with my calculator. So I'm doing it with my calculator. Where do I go to find the area to the right? Second distribution again. This time I'm doing normal distribution, normal CDF. Okay, I am doing normal CDF, so I have to be careful because I'm looking for area to the right. So I'll select number 2. The lower bound, smaller number, is 2.4. The upper bound is positive infinity. Remember how to type it in, 1e to the power 99. This is the E under comma, so second E to the power 99. The mean of a standard normal is 0. The standard deviation of a standard normal is 1. So you're good right now. So if you hit enter, it's asking you, is this correct? Is that what you want? Yes. And so the area to the right is 0.00. Let's see how many decimal places. Let's see, did they give us the number of decimal places? No, they did not. So I'm just going to put it to 3 decimal places. Therefore, the area to the right is approximately 0.008. So the area to the right of this is 0.008. Okay, so this is just a refresher, reminder that you could be told to find the area to the left or area to the right. So it told me to find the area to the right now. Well, in number 6, it told me to find the area to the left of this. The same question, same kind of question. So the first thing you want to do is draw a normal curve. Number 6, draw a normal curve. Any question on normal distribution, draw a normal curve. So I am going to draw a normal curve. All right, so I have the number is negative, so it's on the left-hand side of the mean. So this number is here, negative 0.46, and I'm told to find area to the left of this number. Area to the left means, and this is negative infinity, but you have to write negative 1e to the power 99. Okay, so I'm told to find the shaded area. Remember, you have to draw a normal curve. You have to put in what numbers you are given. You shade the area, shade the area. So you can use calculator to calculate this or read the chart. You can use calculator or read the chart. Okay, but I want to use calculator. And so I can also read the chart later on. I'll read the chart later. So let's calculate the area to the left. The other one we calculated area to the right. Okay, so area to the left is second distribution. And I'm looking for normal CDF because it's area. This time it's area. So what is, I'm going to go back, second distribution, number 2. Okay, and I'll select that. And the argument says, I need to get out of here, second quit. All right, normal distribution. Okay, number 2. All right, and it's asking me, what is the smallest number? Yeah, the smallest number is negative infinity because negative 0.46 is greater than negative infinity. I'm going to clean this and type it in again. So negative 1 e to the power 99 to the power 99. So this is negative infinity. The upper bound is negative 0.46. And then the mean of a standard normal is 0. The standard deviation of a standard normal is 1. So I am going to paste. So I'm going to paste. If I hit enter, I have 0.3228. But they didn't tell me the number of decimal places. So I can leave my answer as answer to this one is 0.33228. Remember that normal distribution. Remember that normal distribution cannot have an area under the normal distribution cannot be negative. So area is never negative. So I want to make sure that you know we have covered this area. And then let's go to the other side. Sometimes you can be given a shaded region. Suppose you are given, find the area of the shaded region. In other words, they drew the normal curve for you. They have drawn the normal curve for you, so it is easier now. You don't have to draw it. So there's not a lot of difference between this one and the ones we have done. So what you want to do is, by the way, everybody look, whenever the absolute value of z is the same, absolute value of negative 1.29 and absolute value of 1.29, whenever they are the same, the area under those curves will be the same. So all I need now is to find area to the left. And when I get the area to the left, area can never be negative. Then I know I have found area to the right. So let's do that. This is called the symmetric property of a normal curve. The symmetric property of a normal curve. So I am going to get my calculator. And I have normal CDF. Second distribution. And then normal CDF is number 2. All right, I'm going to clear. And I'm going to clear this one too. I want to put it in again so you know. The lower bound for area to the left is -1 e to power 99. I'm putting it in again so you can't forget this. And then the upper bound is -1.29, -1.29. And I'm told to find the area to the left. The mean is 0, standard deviation is 1, and I'm going to calculate. All right, so when I do calculate, see what I have. The area is 0.0985 to 4 decimal places, 0.0985, 0.0985. So this area right here is 0.0985. The same area here, because the absolute value of the z-score, they are the same. So this is 0.0985. Because the normal curve is symmetrical. Because the normal curve is symmetrical, the area to the right and the area to the left are equal, because the absolute value of z are equal. Okay. All right, I know you should be able to do the other ones, but this is actually, we just got into chapter 7. Well, let's answer those questions here. This is about normal curve. What is the total area under the normal curve? The total area under the normal curve is 1. What percentage of the area under the normal curve falls above the mean? You can draw a diagram. I'm going to draw a diagram. So the total area is 1. And now I'm asked what is the area to the right of, what percentage of area falls above the mean. So this is the percentage. If I divide 1 by 2, I have 0.5, but it's a percentage. So if I convert 0.5 to 100 to percent, then I know it is 50%. Remember, the question says, what percentage? And since it says, well, what percentage, you leave your answer in percent. So the area under the normal curve for a normal distribution is 1. Yes, true. The area under the normal curve. The Mean, mode, and median are all equal for a normal distribution. The mean, mode, and median are all equal for a normal distribution. Yes, the area under the standard normal curve that lies within 2 standard deviations above the mean from the mean is approximately, that's correct, because that's empirical rule. The area under the normal curve that lies within 2 standard deviations is 95. That's empirical rule. It's true. A distribution is said to be positively skewed if the mean falls to the right of the mean. This is wrong, because it says if the